Now let's look at number 11. Number 11 addresses the two kinds of special products that we learned about in section 9.7. First, there was difference of two squares, and then perfect square trinomials. Let's look at the difference of two squares first. They gave us this formula. If you see a binomial where it's something squared minus something squared, then we write the factors like this. Here's an example. 4x squared minus 16. Now we know that our first step is always to factor out the GCF, and that's what's just been done here. When you factor out a 4, you're left with x squared minus 4. Since x squared minus 4 looks like this, something squared minus something squared, where that something is a 2, we can write the factors as x plus 2 and x minus 2, and that's just what's been done here. So the same way that we were able to use this formula to find the factors of these difference of two squares, you're going to do that here. So we have 5x squared minus 125. Don't forget, first step, factoring out the GCF. Well, 5 is a factor of both, so let's factor out a 5. Now we ask ourselves, is this a difference of two squares? X squared minus 25. Is that something squared? Yes, that's 5 squared. So we have x squared minus 5 squared. Using this formula, that tells us if x squared minus 5 squared is the polynomial, then the factors are x plus 5 and x minus 5. So we still have that 5 out in front, but x squared minus 25 become x plus 5 and x minus 5. Okay, let's try it again. 18x cubed minus 50x. We're going to factor out the GCF. So they both have an x, so we know an x is going to come out. But what about this coefficient? We have 18 and 50. If you're not sure, you can always make a factor tree. So 18 can be broken down into 2 and 9, which can further be broken into 3 and 3. So 2, 3, and 3. 50 can be broken down into 2 and 25, which is just 5 and 5. So we have 2, 5, and 5. What's our greatest common factor here? Well, this one has 2 3s, this one doesn't have any 3s. But the 2 and the 2 are common, and that's all they have in common. So 2 is what we'll be factoring out. So if you factor a 2x out of 18x cubed, that would be a 9x squared. If you factor 2x out of negative 50x, that would be a negative 25. Now that we have factored out the GCF, we're going to use the formula to factor. So is this something squared minus something squared? Well, we know 25 is a 5 squared, so this side's good. But what about 9x squared? Well, 9 is just 3 squared. So let's see, 9x squared, that's just 3x times 3x. So because we are able to write it like this, and it means the same thing, that means it does fit the formula. Something squared minus something squared. Something squared minus something squared. Now that we know this a and this b value, we know our factors are 3x plus 5 and 3x minus 5. On to perfect square trinomials. The perfect square trinomial rule said if you've got a polynomial that fits this form, something squared at the beginning, something squared at the end, and then double this something times that something, then this is your factor. 2 of them actually. So here's an example. We have 2y squared minus 40y plus 200. We always check to see if we can factor out a GCF first, and we can. They factored out a 2. So the 2 is out, and now our polynomial looks like this. Y squared minus 20y plus 100. So now we check. Is the beginning something squared? Yeah, that's y squared. Is the last term something squared? Yeah, that's 10 squared. So now if the a value here times the b value here can be doubled to get the middle term, then we know it's a perfect square trinomial. So y and 10 multiplied together get 10y. Double that, you get 20y. So it does work out. The only issue is that we have this negative sign. So we fill it into this formula, but we know this is supposed to be a negative 10 because of this sign here. Let's do another example. 4k squared minus 88k plus 484. Well, just by looking at it, we see that 4 is definitely a factor. Okay, so we divided each term by 4, the GCF. Now it's time to see, is that a perfect square trinomial? We have something squared at the beginning, something squared at the end. What are those two somethings? That's a k squared, and that's an 11 squared. Is k times 11, can that be doubled to get 22? Yes, but it's got to be negative. So k minus 11 squared. Square the first, square the last, multiply them together, and double it. Gives you the middle term. And that's your solution. Let's try another one. Perfect square trinomial yet again. 12x cubed plus 40x squared plus 300x. See right off the bat that they all have an x in common, but what about these coefficients? We have 12. By the way, if you were in class today, you learned that we were supposed to change this to 120x squared. Okay, so 12x cubed, 120x squared, and 300x. If you have a handy-dandy calculator, and you tried to see if 12 was a factor of everything, then you were very successful. So we know 12 is a factor of 12, 12 is a factor of 120, and 12 is a factor of 300. But we also have to look at the variables. The first term is an x cubed, the second term is an x squared, and the last term is a 300x, just one x. So the most x's that can be taken out are 1. So we'll include an x in the GCF. Now what's left? If we take 12x out of 12x cubed, all we have left is x squared. If we factor out 12x from 120x squared, that would be a 10x. We took one x out of the 2. If you factor out 12x from 300x, you can use your calculator, that's fine. 300 divided by 12 is 25. Since we factored out the x, there's no more x's left. And this is our trinomial. Now we have to check and see, is it a perfect square trinomial? Is the first term something squared? Is the last term something squared? Can we multiply those two somethings, double them to get the middle term? Let's check. The first term is an x squared. The last term is 5 squared. So x times 5 is 5x. Double that, we get 10x. So it is a perfect square trinomial, and we can use this formula to get our answer. And these are our factors. We got to use a plus sign because they were both positive. That's your final answer. Good luck!